In Lesson 5.1, you're going to be solving inequalities by addition and subtraction. And if you recall, you have solved equations in the past, and equations have equal signs. Actually, part of the word equal is in the word equations. But in this lesson, you're going to be solving inequalities, and that involves problems with greater than or equal to, greater than, less than or equal to, and less than. Those are the inequality signs. And so you're going to be solving linear inequalities by addition and solving linear equations by subtraction. For the new vocabulary, you have inequality, which is an open sentence that contains one of those symbols that we just listed. And what we're going to be using is the addition property of inequalities. We're also going to be looking at set builder notation a little bit later. On your notes, make sure that you fill in the symbols for the addition property of inequalities. If A is greater than B, then if we add C to both sides, we're still going to get a true inequality. And if A is less than B, same thing. If we add C to both sides, we're still going to have a true inequality. For example 1, we're going to be solving by adding. And so in this case, to isolate the variable x, we're going to add 12 to both sides. Notice that the example is shown with work horizontally. I will also show an example with it shown vertically. So for the example guided practice, we have 22 is greater than m minus 8. And we're going to use the addition property of inequalities to add 8 to both sides. The reason we're adding 8 is because we want to isolate the variable m. What we're left with is 22 plus 8, which is 30. 30 is greater than m, is the same thing as m is less than 30. Let's check our work by picking a number less than 30, like let's say 20, and we're going to substitute that back in for our inequality. 22 is greater than 20 minus 8. 20 minus 8 is 12, and 22 is in fact greater than 12, so that checks out. For 1b, we have d minus 14 is greater than or equal to negative 19. The addition property of inequalities says I can add 14 to both sides and still have a true inequality. So I'm left with d is greater than or equal to negative 5. Let's pick a number greater than or equal to negative 5 to check. Let's say 0. 0 minus 14 is greater than or equal to negative 19, and that's true. Negative 14 is greater than or equal to negative 19. On page 286, you're introduced to set builder notation. And the way that's read is the set of all numbers x such that x is greater than or equal to 20. So set builder notation is just a more concise way of writing a solution set. And what we're going to use are curly braces, and then we're going to use our variable. This symbol right here is such that, and then we have x, and then we have our inequality, and then we have our number. So just put that to memory, write the definition down, put an example in your notes, and we will apply it here in the next example. You might recall that we can graph inequalities on a number line, and when we do that, we can either use an open circle or a closed circle. Okay, so if it's an open circle, we're going to do that when it's a less than or a greater than symbol, and a closed dot is what we're going to use when we have a less than or equal to and greater than or equal to. So it takes more lead to add that little extra line underneath our inequality. That means we're going to take extra lead and fill in our dot. For example 2, we're going to solve inequalities by subtraction. And please make sure you get this in your notes as well. For the symbols, A is greater than B, then we can subtract C from both sides and still have a true inequality. And if A is less than B, we can subtract C from both sides and have a true inequality. Notice in example 2, we are given our answers in set builder notation. So for the example at the bottom, we have P plus 8 is less than or equal to 18. To isolate the variable P, we're going to subtract 8 from both sides. and we're left with P is less than or equal to 10, and we're going to write that in set builder notation with our braces. P is the variable less than or equal to 10, which is letter G. For example 3, we're going to be looking at inequalities that have variables on each side. And so we have an example here that has 3a and 4a on both sides of the inequality sign here. So we're going to pick a side. In this case, they decided to get rid of the 3a and bring it to the right side, and then solve it, and then graph it on a number line. So let's do that same thing with 3a. Let's subtract 9n from both sides. We could have subtracted 10n to get it to the left side. It really doesn't matter which way, but if you end up getting a negative coefficient, you're going to have to do some dividing, in which case we flip the sign. We're going to get to that later, but for right now, let's just follow this problem by subtracting 9n from both sides. What we're left with is -1 is less than 1n, and then we can rewrite that as n is greater than -1. And if I have a number line here, I can put 0 as my reference point. Here's -1, here's +1. Since it's a greater than sign, it's going to be an open circle at -1, and it's going to be an arrow to the right showing greater than. For 3b, we have 4h on the right, 5h on the left, so I'm going to subtract 4h. Again, I could have subtracted 5h from both sides, but we would still get the same answer. 5h minus 4h is 1h, is less than or equal to 12. And so on my number line, here's 0 as my reference point. Let's just say here is 12. It's going to be a filled in circle. Remember, it takes extra ink or extra lead to put that little line underneath the inequality sign. So we're going to take a little extra ink or lead here and fill our dot in. And we're going to go up and to the left to show less than. And let's just pick a number less than 12 to check. 0 is less than 12. Let's put 0 in up here for our h's. 5 times 0 is 0. 0 is less than or equal to 12 plus 4 times 0, which is 0. And that does check out. On page 287, you have a nice little concept summary, phrases for inequalities. Please fill in the inequality symbols for each of these. Less than is the same as fewer than. Greater than and more than, at most, no more than, less than or equal to, and then at least, no less than, greater than or equal to. For the next example, we're going to be translating story problems into inequalities and then solving them. So you see right here that we have Felipe needs the temperature of his leopard gecko's basking spot to be at least 82 degrees Fahrenheit. And currently it's 62.5 degrees Fahrenheit. How much warmer does the basking spot need to be? So we have the current temperature, and it needs to be at least 82. And if we have T as the temperature, and we add what the current temperature is, we want that to be at least 82 degrees. And then we're going to isolate the variable T by subtracting 62.5 from both sides. And then we find out that that spot needs to be at least 19.5 degrees Fahrenheit or more. So let's take a look at number 4, the shopping. Sanjay has $65 to spend at the mall. He bought a t-shirt for $18 and a belt for $14. If Sanjay wants a pair of jeans, how much can he spend? So we'll say J is jeans. And if we add in what he's already spent, 18 plus 14 is $32. He has only $65 to spend, so that has to add up to be less than or equal to $65. So in order to isolate the variable J, or find out how much he has to spend on the jeans, we can subtract 32 from both sides. Sorry, it's running into the text there. And we get J is less than or equal to $33. So he cannot spend more than $33 on the jeans. I just want to point out two more problems that have variables on both sides. If you look at page 288, number 7 and number 8 both have variables on both sides. When I have variables on both sides, I'm really aiming to find a coefficient that's greater than 1. I don't want a negative coefficient. And so in number 7, I have 8r and 9r. So if I take away 8r from both sides, what I'm left with is 6 is less than 1r. And again, that coefficient of r is a positive number, which is what I want. It's not wrong to have a negative coefficient, but if you do, you have to worry about flipping the inequality sign. So 6 is less than r is the same thing as r is greater than 6. For number 8, we have 8n and 7n. If I subtract 7n from both sides, 8n minus 7n is 1n is greater than or equal to negative 3.